Hello, everyone. Thank you for coming to our session on VolumeGroupSnapshots. My name is Xing Yang. I work at VMware by Broadcom. I'm also co-chair of Kubernetes 6 Storage.
And my name is Leonardo. I'm a principal software engineer working in EDB. I'm a Postgres user since a lot of time, and I'm a contributor to the Kubernetes CSI project and a maintainer of the Cloud Native PG project.
Here's today's agenda. We will discuss why we need VolumeGroupSnapshots, explain how it works, and how to use it. At the end, we will do a demo. When I was preparing for this presentation, I asked ChatGPT to show me why disaster recovery is important. Here's what I got. It looks chaotic and dangerous all around, but in the middle of this picture, it looks calm and safe. This is definitely better than what I can draw. Here we have a data center being protected from disasters such as fire, flood, cyber attacks, a shield that safeguards your critical data, a contrast between chaos and security. Disaster can happen at any time. How do we protect our precious data from potential loss? Here I listed what could cause a disaster. Actually, human error is one of the leading factors. As shown in this picture, if this data center is burned down, your data stored there will be lost for sure. However, if you have your data backed up in a different location, you can always restore your data back. So data protection and disaster recovery are very important for your mission-critical applications. VolumeSnapshot API was introduced back in Kubernetes 1.12 release and moved to GA in Kubernetes 1.20 release. It allows you to take a crash consistent snapshot of a persistent volume and use that to restore your data back at a later time if a disaster strikes. It provides a basic building block to protect your applications running in Kubernetes. We already have a VolumeSnapshot API for individual volumes, so why do we need VolumeGroupSnapshots? Now let's take a look at an example. Suppose you have an application running that uses multiple volumes to store its data, logs, and so on. You want to protect your application. To ensure application consistency, you need to quiesce your application before taking a snapshot and unquiesce afterwards. But quiesce takes a long time and it is very expensive, so you may not want to do it frequently. But you still want to be able to back up your data more frequently. Without application quiesce, you take a snapshot of the first volume at time 1. Then you take a snapshot of the second volume at time 2. Then you take a snapshot of the third volume at time 3. Now you try to clone the same application to a different namespace, or maybe your original application is corrupted somehow. You are trying to restore your application back from those snapshots. Now after restore, you may run into problems because the snapshots were taken at different times and you get inconsistent data. How do we solve this problem? Fortunately, we have consistent group snapshots come to the rescue. Consistent group snapshot allows a snapshot to be taken from multiple volumes at the same point in time to ensure right order consistency. This is important for applications that have multiple volumes. After taking the consistent group snapshot, you can create a volume from the snapshot and get your application back. Note that if your application is a database, you will still need to do crash recovery. Leonardo will give an example later. Volume Group Snapshot feature supports crash consistency. Taking snapshots of all the volumes at the same point in time also is more efficient than taking one snapshot at a time. It provides better performance. We started to design the Volume Group Snapshot feature shortly after Volume Snapshot moved to GA in 1.20 release. But it took a while before we finalized the design, and we introduced it as alpha feature in 1.29 release. Then we moved it to beta in 1.32. This feature introduces 3 new APIs. We have a volume group snapshot class that is created by an admin to describe how volume group snapshots should be created. We have a volume group snapshot that represents a user's request to create a volume group snapshot for multiple volumes. We have a volume group snapshot content that represents a physical volume group snapshot resource on the storage system. The content is created by the snapshot controller in a dynamic provisioning and created by the admin for the pre-provisioning case. Leonardo will explain the 2 types of provisioning later. In a volume group snapshot class, we have the CSI driver name, the parameters that contain information that is opaque to Kubernetes and is understood only by CSI drivers. It contains the deletion policy. This works the same way as the deletion policy in a volume snapshot class. It can be either delete or retain. Here's an example of a volume group snapshot class. The deletion policy is delete here. Here is the volume group snapshot API. In the spec, you need to specify the source. The source can be either a label selector or a volume group snapshot content name, depending on the type of provisioning. Volume group snapshot class name may be left nil to indicate that the default class will be used. After volume group snapshot is created, you can see the bound volume group snapshot content name and the creation timestamp in the status. You'll also see the ready to use parameter in the status that indicates whether this volume group snapshot is ready to be used to restore your PVCs. Here is an example. See the label here. You need to specify the label on all the PVCs you want to be snapshotted together. In the volume group snapshot content spec, you have the deletion policy, CSI driver name, volume group snapshot class name, and the source. The source can be either a list of volume handles for the volumes on the storage system or group snapshot handles, which includes the volume group snapshot handle and a list of individual snapshot handles on the storage system. The volume group snapshot and volume group snapshot content have a one-to-one mapping to each other. In the volume group snapshot content example here, we see volume handles in the source. In the status, we see volume group snapshot handle and the list of individual volume handle and snapshot handle pairs. To support this feature, we also added volume group snapshot definition in the CSI spec. This feature in CSI spec moved to GA in the CSI spec 1.11 release. CSI spec does not have a beta phase. We added a new group controller service and a new capability. We added 3 new RPCs: create, delete, get, volume group snapshot. In order to support this feature in a CSI driver, a storage vendor will need to implement this new controller service and the new RPCs. In this diagram, we show how CSI driver is deployed and how various components that support volume group snapshots are working together. We added the volume group snapshot support through the snapshot controller and the CSI snapshotter sidecar. Snapshot controller does the heavy lifting. It creates the volume group snapshot content, and in case of dynamic provisioning, and it is responsible for binding the volume group snapshot and the volume group snapshot content. The CSI snapshotter sidecar is deployed together with the CSI driver. It watches the volume group snapshot content API objects. It calls CSI driver to create or delete volume group snapshot on the storage system. We introduced feature gate in both snapshot controller and the CSI snapshotter sidecar. Since this is the beta API, the feature gate is disabled by default. Now let me hand it over to Leonardo. He will explain how the two types of provisioning works.
Okay, so there are three main things you can do with volume group snapshots. The first one is called dynamic provisioning, and it is the workflow you use when you need to take a backup. And given a volume group snapshot class, you need to create a volume group snapshot object, and the system will provision everything for you. So a volume group snapshot content, a set of volume snapshots, and a set of volume snapshot contents. Isn't it beautiful? It's magic. From just one object, you're going to get everything. The second workflow is called pre-provisioning, and this is what you use when you want a Kubernetes cluster to take control of an existing group snapshot existing already in your storage. For that workflow to work, you need to create all the objects yourself. So the volume group snapshot content, the volume group snapshot, the volume snapshot contents, and the volume snapshots. Then the third, the most important workflow is the restore. And this is really easy to do because it's just designed to be used as you would use a plain volume snapshot. We'll see that later. And from now on, we are going to explain how the dynamic provisioning works. And you know, since I'm an Italian guy and I love classical music and opera, I will use an opera metaphor. So we split this process in 4 acts, and each act has scenes. And this is an opera for 4 personas. You have a Kubernetes administrator, you have a CSI driver, you have the snapshotter sidecar, and the common snapshot controller. So let's start from Act 1. So what happens now? You are a Kubernetes administrator working on your desk. Everything is good, everything is fine, and suddenly a developer enters asking you for a database. Do you really need it? Yes, I do. But it's just temporary data. Don't worry. You can destroy everything when you want and recreate it back. I don't trust temporary data. Let's create some storage for it. And I know that it's always best to have the transaction log in a separate volume. So I'm going to create 2 PVCs. One is for data. This example uses CMPG because it's the operator I'm most familiar with, but concepts are generic. The second one is for the transaction log. In Postgres, this is named wall, write-ahead log. The most important bit here is the common label between the persistent volume claim of data and the other one of the walls. It's named, in this example, instance name. Then I configure immediately a volume group snapshot class because it's better to feel safe than worry. You know, I'm going to back up everything, and if it is temporary. OK, Act 2. And now we are inside the kube controller manager. You know, everything is good. Someone created a cron job, and the cron job starts handling a YAML definition of a job to the job controller. And the job controller is one that always complains because it wants to be used in isolation, and everyone uses just the cron jobs. But anyway, let's work. I'm going to create a pod for you. It's fine. And this pod is triggering your database operator to take a backup. And the database operator, it is a quiet place. There's back going on. Back is perfection. Beautiful. What is doing the database operator is creating a volume group snapshot object. And look at that. We have the labels, the instance name label we have seen before. Isn't it beautiful? And we have the reference for the VolumeGroupSnapshot class name. This comes from Act 1. OK, we have a new object. The snapshot controller is waking up. Oh, look, I have a new object. Let's create a content for it. I'm going to get all the details about the volumes you need to snapshot. So I fill the volume handles, everything. Beautiful, OK. And now we are inside the pod of the CSI driver. And there's the snapshotter sidecar realizing that there is a new VolumeGroupSnapshot content object. OK, but I don't know how to take a snapshot by myself. I need to ask my CSI driver friend, which is sitting next to me. And so I scream in a gRPC format, create group snapshot request. But that poor guy is sitting just next to me. So, look, I heard you. OK, these are the UID. I'm going to do your work. Good. OK, let's take a group snapshot. These are the UIDs of the snapshot you requested me. And this is the UID of the group snapshot. And you know why group snapshots are so fast? It's because the snapshotter is continuing screaming at the poor guy sitting next to him until it is ready. Oh, good. OK. Let's do that. So I'm going to fill all the details. It's everything there, these magic numbers, all the UIDs, and it is ready to use immediately. Beautiful, in this example. The snapshot controller wakes up again because the object changed. So I now have a VolumeGroupSnapshot object. I have a VolumeGroupSnapshot content objects. I need to create a set of volume snapshots and a set of volume snapshot contents, because this is what you need when you need to rehydrate your PVC. I do that just using the data they were sent to me in the step before. And I'm going to create everything. This is how the magic works. But you know, again, since I created new objects, the snapshotter sidecar wakes it up. Oh, there's new object. Let's ask the poor CSI driver the status of this object. I already told you. They are ready. OK, let's do it. I'm going to fill the status. Good. I have the status now. They are ready to use. They have a volume group snapshot handle. This classifies them as a member of a group snapshot, not just individual snapshots. Act 3. OK, we go back to our office. Everything is good. And, you know, the developer comes asking for a restore. It's always happening. But it was temporary data. Yeah, but, you know, it's taking so long to recreate from scratch. Can you restore as it was 2 days ago? OK, let's do it. OK, it is enough to recreate a persistent volume claim and use the data source stanza inside the specification, referring to the volume snapshot objects that were created a few steps before. This is just like you would use a plain volume snapshot. We want restore to be easy, because when you need to restore something where usually are having troubles, it's better to avoid complexity. This is so important. This is why it works that way. Act 4. The world is quiet and beautiful, and we finished. And that's it. So this is how dynamic provisioning works. And as you can see, it is teamwork. It is not just one software component doing the magic. It's collaboration. So the most important here is the communication between all these software components. This is more important than the actual implementation. And if something doesn't work, OK, we need to know that this is a beta feature now, and we need to check the features gate to be enabled. There are feature gates in the common snapshot controllers. There is a feature gate in the CSI snapshotter sidecar. And then we need, obviously, the CRD to be installed. And we need to check that the PVCs can be really snapshot together at the same time. At least they need to be provisioned by the same CSI driver. And that CSI driver is the one that should be referred to in the VolumeGroupSnapshot class. OK, I checked everything, but it still doesn't work. Well, so you know the history. You know which actor is supposed to play. Now the logs are your friend. and you need to check which step you stopped and what happened. And then we need to iron out some bugs. But anyway, OK. So I'm a Postgres person, so I need to share a few words about Postgres. But this is true for many software systems working like a DBMS. So you get basically 2 data stores at the price of 1. The one on the right is called the transaction log. And every time you change something, someone is adding a note there. And when you commit, this is flushed down to permanent storage. And periodically, the system will perform a checkpoint. Checkpoint means it's going to flush down all the cache to your data store, which is the one on the left, and can be split in multiple volumes, like in this example. So to backup a system like that, you need collaboration between the primitives, just like volume snapshots in this example, and the database operator. So someone needs to start the PG backup start function, which is going to turn a few knobs inside the DBMS and immediately perform a checkpoint. The system is consistent at that point, and then you can take your snapshots. When you did that, you need to run PG backup end. This stops the backup process. When you need to restore this situation, it is inconsistent because snapshots are taken at different point in time. The database will just look for the checkpoint immediately before the first snapshot, so the one where PG backup start was performed, and then apply back all the transaction log until it is consistent. This is going to take a bit of time because they are not consistent. Meanwhile, with group snapshots, this is easier because everything is consistent, and it's going to be really quicker. This is why group snapshots are really loved by database people like me. It's such a great feature for us. So let's do a little sacrifice for the demo gods. And I hope it is big enough. Can you see it? Is it big enough? Good? Good. OK. So this is a cluster object. I'm using CMPG, but everything is generic here. I just created a cluster object with just one instance. That means you are going to get just one pod. But this database is split across multiple volumes. You want it bigger? That's good. Huh? Better now. Multiple volumes there. There are 7. Yeah. OK. To backup this system, I'm running the CMPG backup command. It is no magic, absolutely. It's just creating a backup resource that is triggering the database operator. And wow, this is nice. It's going to trigger even an update of item. Oof. OK, it's fine. Anyway, our backup started, finished, and completed. This is what happens when you turn on your Wi-Fi. OK. How did it do that? It just created a volume group snapshot object, which is ready to use. Look at the definition of this. The most important bit is this selector. OK. And then you get everything else because CMPG is annotating it with the database status. But this is something for CMPG. Then you are going to get a volume group snapshot content object, as we were saying before, which is ready to use. And then you are going to get a set. Oh, this is the definition of the volume group snapshot content with all the mapping between the UID of the volume and the UID of the snapshot. And then we get, poof, OK, a list of volume snapshots, one per PVC. This is nice, so you get a reference of the name of the PVC that was not snapshot, and a list of volume snapshot contents. Here it is. So it's really easy to use them, and it's teamwork. So great. I'm going to start my presentation again. Poof, poof. There we go. Back to Xing.
Thanks, Leonardo. Now that the feature is beta, we have been working on fixing bugs and trying to bring this feature to GA. We'd like to see implementation from more storage vendors, and we'd like to see integration for more Kubernetes applications, like the backup restore use case that Leonardo described for the PostgreSQL operator. Here are some resources for your reference. That's all we have. Thank you.
Yeah. I have a question about the demo. Like in the demo, you showed a volume that was 2 gigabytes. How it works how quick it works if we have some larger volumes attached?
Okay, the answer is it depends on how your storage is implemented. This is just an infrastructure. So yeah, sorry, I don't have a clear answer for you. Check your CSI driver. You will find a lot of documentation about this works internally. It may be immediate or it may take some time, depending on if your CSI driver implements secondary storage or not too.
Yeah, definitely depends on how your storage works.
Okay, thank you.
Hello, I have a question about the demo also, about the restore with CNPG, because in the CNPG documentation you need to delete the cluster and recreate from a backup. Does it mean that with volume group you need just to restore the volume group, right? And without touching the cluster object?
Yes, when the volume group snapshot feature will be merged inside CNPG, you will just be able to reference the volume group snapshot object, and then you are done.
Okay, so it's not available yet, right? But
Not in this
CNPG
moment.
need to change?
Yeah, it will be merged, I hope, for the next release.
Okay, thank you.
Okay, thanks for the presentation. I want, if I can, I would like to answer also the question before about the recovery time, because I did a presentation in KubeCon in I think Chicago a year and a half ago, where Michelle Au from Google, we showed how to restore a Postgres database of 4.5 terabytes in 2 minutes. As Leonardo explained, volume snapshots are still at the foundation on this. But I would like to ask you if you can briefly cover the differences between snapshotting in VMs and the benefits that Kubernetes has brought to this technology that is unprecedented. I mean.
Okay, so you're talking, okay, the VMs, right? So
yeah, VMs or outside Kubernetes. I mean, the advantage that Kubernetes
right.
has
So
brought.
with this feature, if your VMs are using multiple volumes, you can take a group snapshot. That will be very helpful for your VMs, right? Because your VMs typically have multiple volumes.
Yeah, and to add a bit of something, this is a foundation work that is common to every storage implementation. So you just have an API, and using that API, you are independent on the actual implementation.
Yeah,
I don't know if this answers your question.
Sorry, I probably phrased it wrong, but mine was, I've seen from a user's point of view, the advantages of having a standard interface that Kubernetes brings when taking volume snapshots, that it's not available in VMs where every vendor has their own. Sorry, I should have
so
phrased it this
if
way.
your VMs have all the data stored in the PVCs, you can use this.
Yeah.
You can use this feature to take group snapshots.
Okay.
Yeah.
Thank you.
Thank you for presentation. I have a question. In your selector, you're using only host name. Is it possible to use different attributes in a selector?
Absolutely. Absolutely. It's just a plain selector.
Okay. So
this is foundation work. It's not about a particular implementation. It's for everyone to use.
So potentially we can make a multi-port snapshot.
Absolutely.
Okay. Thank you.
One clarification question. Are you calling this CSI provider with a list and delegating consistency to them, or are you taking responsibility for consistency and calling them parallel?
So CSI driver needs to implement this one and need to call their vendor-specific APIs, right?
Yep.
If they support consistent group, then they can use this, they can implement this.
Okay.
But if they do not have that yet, then it's not going to work, right? So this depends on whether a vendor supports this technology or not on their system.
You need adoption from each vendor that's providing a CSI driver to handle
Yes.
that consistency, and they can implement that however they want in the back end.
Yes, they can. Yeah, they can implement this one if they have that feature in their storage system. Yeah.
Do you know, out of the major vendors, who supports it yet?
So right now, it's a bit early. Last time when we asked, there are like a couple of companies saying they have implemented this. So that's why I was calling for implementation for more storage vendors.
Okay. Thank you.
Any tentative timelines when this feature will become GA?
So we just moved to beta in 1.32. So right now we are fixing some issues. Probably need some soak time. This is just tentative, right? Maybe 1.35 release. So we'll see.
Thanks.
Hello, buongiorno. I would like to ask, when you take the snapshot and the snapshot operator cooperate with the CMPG operator, and you have to issue the PG start backup command, it has to flash the wall to the disk to be able to take a consistent snapshot. How does this affect performance? And if this affects performance, because I imagine that I wonder that in that case, write will be locked for a moment to the database.
Yeah. So this is actually Postgres specific and not about. But yeah, okay. With Postgres, you can spread your checkpoints across time to avoid the spike of your workload just when you perform a checkpoint. So it depends on how you configure your engine. But you can definitely avoid that spike, at least a good part of it.
Okay, thank you.
Oh, sorry, I just need 1 more minute or 2 minutes of your time. I would like to thank Xing for all the help she gave me when I started contributing to the Kubernetes CSI ecosystem. She set an example, both at the technical level and the personal side, as to be a really good leader on the tech storage initiative. A big round of applause for her.
Yeah, thanks, Leonardo. You have been contributing a lot to this feature, and also there are many other community members who are contributing to this feature. They are not in this presentation, but I want to thank all of them for contributing.